Okay, so what we're talking about today is quadratic inequalities in one and in two variables. And I actually got these two mixed up. This is two, this is one. So they're kind of the same process, but a little different. We're going to start with the more basic ones, which are the ones that I think are more straightforward, which are the y variables. Okay, and so you're going to graph the parabola, and you can graph it knowing the vertex. Or you could graph it by finding the vertex by doing negative b over 2a, okay? And so we're going to do two problems. The first two problems are graphing here. Remember that when we do these, you have open circles or closed circles or open lines or dashed lines. So maybe we should write this information up here. Remember, if you have anything without a line underneath it, it's going to be dashed. And if I have a line underneath it, then it's going to be solid. And then we're also going to have inequalities. So if I have a less than or a less than or equal to, I'm going to shade, this is a less than, I'm going to shade below the vertex. And if it goes this way, below the vertex is inside. Okay, so it kind of depends on which one you have. So if you have a y is less than and it's positive, it goes up and you shade below. Or if it goes down, below happens to be inside. So if I have a y is greater than or a y is greater than or equal to, then if it goes up, above the vertex is inside this time. But if it goes down, above the vertex is on the outside this time. So it's not based on the inside or outside, it's based on going above the vertex or below the vertex. Okay, so let's look at this first one. I'll zoom in for us. So this first one is nice because it's in vertex form. And so this tells me that it's going to go down. And then my vertex is at 4, 1. So I'm going to go to 4, 1, 2, 3, 4, and 1. And then I know it's going to go down. So the other thing I need to know is that this is going to be a dotted line. So it's a dotted line going down. And this time it says shaded below. This says less than. So here's my vertex. Below my vertex happens to be inside for this problem. Okay, over for the second one. The second one, I have a vertex, but I also just know that this goes up to 4. And you see how there's no number in the parentheses? Then the vertex is at 0, 4. This one is going up because it's a positive number in front. That's positive. And it's going to be a solid line because it's greater than or equal to. Well, when it says y is greater than or equal to, I shade above the vertex. So for this one, above the vertex happened to be inside. Now, please be careful because both examples I gave happen to be inside. They are not always inside. It kind of depends on which direction the parabola is going and if it's a greater than or less than. Okay. All right, so when you're solving in one variable, there's no y, it's just one variable. The first thing I'm going to do is I need to factor. And if you notice, it has to equal 0. If there's not a 0 over here, you got to make it with a 0 there. And then I factor, and then I graph my zeros. And remember, your zeros are just the solutions. And then what's going to happen is if it's a positive x squared, it goes up. And if it's a negative x squared, we're going to make it go down. Now, we don't actually do anything with the curve. The curve just is going to help us know whether it's an and or an or problem. Because when we're doing with these types of inequalities, that's what's going to happen. You're going to either have an and or an or. Okay, so let's look down here at the first one. So the first thing you need to do is you need to go ahead and factor this. So what times what is 21 subtracts to give you 4? Well, I know that's 7 and 3. And the only way I can get a -4 is if my bigger number is negative, if I have a -7. And so I have it factored. The second step said to find my zeros. Well, my zeros are just the opposite of parentheses. So this 0's at 7, and this 0's at -3. Well, what I do now is I just draw a rough sketch where I put -3 and I put a 7. And then I have to see if it's positive or negative. Well, this number in front is a +1, so I know it's going to go up. Now, what's important is you have to think about this parabola kind of as string. And I'm supposed to only shade my parabola where the string is greater than 0, and the 0 is this number line. So my string is greater than 0 above the number line. So I shade my string to the right and to the left. Now, if I were to straighten this string out, this string would go to the left and this one would go to the right. And what I hope you notice is that we just created an OR problem because it went one way or the other. And so at -3, it goes to the left, so it's less than. I don't put an equal sign underneath it because there's not one for the original problem. And then at 7, it's greater than because it went to the right. So again, the first thing you do is you factor it out here. You find your zeros, graph your zeros on a quick number line, and then you see if it goes up or down. And from there, we shade. Okay. All right, so let's try another one. So my issue here is that this needs to be here. So it's going to become x squared plus 5x minus 6 is less than or equal to 0. I need to factor this. And so my factors is 6 that subtract to give me 5 are 6 and 1. And the only way I can get a +5 is if my bigger number is positive, so 6 is positive. And so now I have a -6 and a +1. So -6 and +1. Again, up front, that's a positive number. So it goes up. But this time I'm supposed to shade below. And my string goes below right here. Well, if you notice, that's in between two things. So this is an AND problem. So you can say -6 is less than x and less than 1. Oops, we can't forget our inequalities are underlined. Or you could say x is greater than or equal to -6 and x is less than or equal to 1. Both of those answers are acceptable. Okay, so what I want you to do now is I want you to look at these 2 problems or 3 problems, if I can get them all on the screen, and I want you to factor them and see if you can find the zeros and graph a number line. When you think that you're done, press play again so that you're ready to check your work. Okay, so you should have factored this and gotten x plus 1 and x plus 9. So I get a -1 and a -9. So I draw my real rough graph of -9 and -1. It is a positive x squared, so I still go up. And if you notice, it's kind of a pattern. Most of the time, you're going to go up. And so now it says less than 0. So I go below. And so it's in between -9 and -1. So this is an AND problem. Okay, for number 28, or number 2, the first thing you should have done was moved over that -28 by adding 28. And now I'm going to factor this. What times what is 28? Adds to give me 11. Well, that's 4 and 7. And the only way I can get a -11 out of those is if they're both negative. So that means my zeros are 4 and 7. So I graph my 4 and my 7. And again, this is positive again, so I'm going to go up again. And this time it's greater than 0, so I shade my line greater than 0. So this one will go to the left, This one would go to the right, so I created an OR problem. So x is less than or equal to 4, or x is greater than or equal to 7. Okay, last one. I need to move this over. So I get negative x squared minus 8x minus 7. Well, look, I finally got a negative. But before we can factor it, we're going to factor out that negative. And so it's going to be x squared plus 8x plus 7. Well, now what times what is 7 adds to give me 8? Well, that's 7 and 1, and it's a positive 8, so they're both positives. And so now I do the opposite, so I get a negative 7 and a negative 1. But this time I finally have a negative, so I'm going to finally draw my curve down. But it's the same concept now. Do I shade my curve above the line or below? And this says it's greater than 0, so I'm going to shade it above. So this is an and, it's in between there. So negative 7, x, and negative 1. So just a quick recap. Remember when you're graphing these, if you have a y values, you shade a region. Okay? If you just have x's, then you're more looking for this process where you're trying to find out where a solution is. Now, I do want to show you a couple things. If I have a problem that looks like this, sometimes you're going to get a problem that touches just once. On a problem like this, if it's greater than 0, this whole graph is greater than 0, so I would shade everything. So this solution would be in all reals. But if I had the same situation, but it said less than 0, well, this graph never crosses below this axis. And so for this one, it would be no solution. So if you get a graph that touches only once because it's the same factor twice, then you have to recognize whether it's going to be an all reals or a no solution.